Welcome back. In this lecture, you'll understand about mounting, mount points, and also bind mounts. So, first of all, what is this mounting? Assume that I have a machine with operating system, and I have this storage device. Normally, in storage device, what we do is we do partitioning. We'll have multiple partitions on a storage device. Normally, we have a storage devices named like this slash dev slash sda 1 slash dev slash sda 2 etc. Now what we do is normally we actually bind these partitions to some folders on our machine. Maybe slash sda2 is bound to slash sda1 is bound to slash x, maybe slash dev maybe slash dev slash sda3 is bound to slash y. So what we are doing is we are actually binding partitions onto folders. So whenever I'm writing to slash, I'm writing to this partition. Whenever I'm writing to slash x, I am writing to this particular partition. So like that, we abstract the underlying device related details or underlying file system related details by mounting the partitions onto some drives. This is called as mounting. And these drives, these folders are called as mount points. For example, I will tell you right now. I'll show you on my Windows machine. This is my folders. There are two folders, drive C and drive D. Suppose if I am putting my pen drive or USB drive, you can see that automatically the drive in Windows, automatically my pen drive is mounted onto E drive. This is auto mounting, but we can also do manual mounting. In Unix, what we can do, we can mount any partition onto any folder or a drive like this. So you understood about mounting. Normally we mount partitions onto some folders. Okay, but one more thing also we can do. What we can do is on a particular operating system, assume that I have directory slash a slash b. In slash a, I have 1.txt, 2.txt. In slash b, I have 3.txt and 4.txt. Now what I can do is I can superimpose slash a onto slash b. That means I can actually bind a onto the path existing path b. So I'm actually doing a mounting of A onto B. I'm actually binding slash A onto slash B. So this is called as bind mount. So actually bind mount, what we do is in bind mounting, we actually bind one directory onto another directory. That is called as bind mount. How do we do it? I will show you. But once I have mount slash a on top of slash b, after mounting, if I use ls slash b, what will I get? Will I get the contents of b? No, I have mount a onto b, right? It will give me the contents of a 1.txt and 2.txt. Now whatever operations I do on b, actually I am doing it on a. Suppose if I create a file 5.txt on inside b, actually I'm creating this inside a, so automatically in a directory 5.txt will be created, right? So let me demonstrate it. You might be wondering what is the use of it. You'll understand clearly the use of it, but let me demonstrate it by logging into my VM. Okay, so Here, I'll create a directory mkdir a and also b. I'll cd into a. I'll create two files, touch1.txt and also 2.txt. Else, yes. So I'll again go to b and I'll touch 3.txt and 4.txt. Okay. Now what I will do is I'll come back. I have two folders A and B. I want to superimpose A onto B. So I'll do mounting. Sudo mount dash dash bind. I'm doing a bind mounting. So dash dash bind. What? I want to superimpose A onto B. Okay. Now if I ls B, what? It is showing the contents of A. Inside A I have created 1.txt and 2.txt. So that is the thing. Now suppose if I create, I'll be inside B, CD B. Now inside B, I'm creating 5.txt. And if I ls, okay. But actually, is this 5.txt created inside A? Yes. So whatever I was doing in B, actually it will get reflected in A. Now, if I want to see what is this mount point, the command is df-a. It will list all the mount points. You can see at the last slash home, my home directory slash b is a mount point. Okay, slash b is a mount point. Now, how to unmount it? What I can do is sudo umount b. Yes. Now, if I ls b, see, I'm seeing the original content of B. If I now ls A, I'll see 5.txt which was created earlier. Now, if I use df-a, will I see the mount points for slash B at the last? No. Fine. That's about mounting and unmounting. I'll tell you one interesting thing right now about another file system called as proc file system. Suppose if I execute ps, it will list all the processes, right? Suppose if I write ps-aef, it will list all the background processes and system processes, everything. So the PIDs are starting from 1, right? Lot of processes are there. So when I execute ps-aef, how is my operating system knowing what all processes are running? Internally, operating system maintains something called as proc file system. Okay, it is mounted under slash proc. See, if I do ls slash proc, it is showing the process IDs. And now if on the other terminal I write ps dash aef, see all the process IDs here. Let me clear all of them. Okay, ps dash aef, you can see all the process IDs starting from 1. Whatever numbers you are seeing in this one, you will be able to see whatever processes are listed are coming from this proc file system. Now if I say df dash a, you can observe that a file system called as proc, this is actually not a partition. It is a system specific file system. All the information about processes are stored in this, and this proc file system is mounted on slash proc. So all these process IDs, the information about them is coming from the proc file system. Now let us see is ls slash proc. Okay, suppose if I go inside any process, like say ls slash proc, /1. Okay, permission denied. I will use sudo. So you can see there are multiple folders which show the information about this process with ID 1, right? There are a lot of folders which we don't understand, but understand that whatever files or folders under this proc/1 are related to process with ID 1. Okay. So this proc file system is mounted onto slash ls, sorry, df dash a. You can see this proc file system is mounted onto slash proc. I'll do one thing. I will unmount this slash proc. Slash proc is a mount point, right? I can unmount. Sudo u mount. Actually, this proc is not a bind mount, right? It is actually bound to a system service icon. I have to use -l proc, -l slash proc. So I have unmounted it. Now if I try to see the df dash a, oh, it's not able to read the table of mounted file systems. And even if I say cps, it is saying error. It's not able to retrieve the information about the processes because we have unmounted slash proc. So again, to mount, what you can do, mount dash p, which file is dash t, mount dash t, which uh, say file system, proc file system, and this is system proc slash proc. This is a command to mount again back. Only root can use this. Okay, so I'll have to do sudo. Okay, done. Now if I do ps dash aef, again I will, sorry, dash, single dash. So I'm getting all this from the proc file system. So remember that if I do df dash a, remember that this proc file system is mounted to slash proc by default. Okay, now once we understand all this, let us try to understand that in an operating system there will be a default mount namespace. So if this is my machine, I have the operating system. We understood that for the operating system there will be a default PID namespace. Similarly, there will be a default mount namespace. So as we understood earlier, if I want to see the namespaces, LSNS, these are all the namespaces, PID namespace, mount namespace, these are all the defaults. Now I want to create a launch my process in a separate mount namespace. How to do it? Very simple. Again, sudo unshare. I want to unshare a namespace -m, and then I want to fork a process in this namespace -f bash. So this is how you can actually create launch a process, fork a process, which is unsharing the mount namespace. Suppose if you want the process to have a separate process namespace, you can use like this. Now, if I do ls-ns, you can see um, there is actually a mount namespaces, multiple mount namespaces. There's one namespace at 40. Is this 40 listed? Yes. And it is actually showing from various other locations. I'll tell you the reason why you are actually seeing all these options. I will exit first right now. What I will do is I'll execute same unshare command, but I will also use something called as dash dash mount dash proc. We'll understand what is the importance of it. So this will actually create a separate uh, pro- process ID namespace and also mount namespace, and in that we are actually forking bash process. Now if I do lsns, okay, it will show all the namespaces. Now without this, in another terminal, if I say lsns, this is in the parent. In the parent, what is the mount namespace? It is ending with 840. Here the mount namespace is 289, different. PID namespace 836, here 290, right? So we are actually running our bash process in a separate mount namespace and also process namespace. That's how we can actually do that. Now, uh, before I explain about this dash dash mount proc, what I will do is, here again in another terminal also I'll create sudo unshare dash f for forking, and also I want an unshared process namespace, mount namespace, and then I'm using dash dash mount dash proc, and then I want to start bash. Okay, now ls. So again I'm having directory A and directory B. ls A right now 2 1 2 and 5 is there, right? I'll remove this file. Oh, sorry. I have to be in a directory. ls5. Sorry. rm5. Okay. ls. Fine. Now lsa, lsb. Fine. Now I'm in a separate mount namespace, right? In this mount namespace, I will do a bind mount. Sudo um, mount dash dash bind a onto b. Sorry, bind spelling mistake. Okay, now if I do lsb, I am seeing the content of a. But in a separate namespace, if I write lsb, I am seeing the original content. That means changes made in this particular mount namespace are not visible to other namespace. Right? Fine. Now, what I want is in this namespace, um, I want to see the uh, processes ps-a. I am seeing only these two processes ps-aef. I am seeing only these two, the bash and ps-aef. I am not able to see the processes of the parent. Why? Because let me tell you what is the command which we used. We used dash dash mount dash proc, right? What this mount dash proc will do is, in this current namespace, it will unmount the parent namespace and mount it back. So, uh, in this again newly mounted proc file system, you will be able to see only the processes in this current namespace. Okay, let me explain you. Let me actually run this without dash dash mount proc. Okay. Now I am in the separate process namespace, right? If I do ps dash aef, oh, it is listing all the processes of the parent also, even though I am in the child process namespace. From where is it getting? It is getting it from slash proc. See all these process IDs, right? So now I'm in the child namespace. I wanted to unmount sudo umount dash l slash proc. I am unmounting the proc namespace. And now if I do ps, it is saying you have to mount it back. So what I will again do this mount sudo mount dash t proc slash proc slash proc. Now I'm remounting it, right? Let us see what will happen. Now if I do ps dash, or now if I do ls slash proc, see, am I actually seeing lot of process IDs? No, I'm seeing only the process IDs in the current shell, current bash shell, ps-aef. See, I'm seeing one. Of course, this ps-aef is a new PID, but the bash is one, right? So that means I have actually unmounted the parent's proc file system and remounted it. So if you unmount the parent proc file system and remount it, it is like a new proc file system which contains only the information about the processes, right? So I will exit now. What I did earlier, I created a namespace without dash dash mount dash proc. I did. And if I have done without dash dash mount dash proc, I have to do manually unmounting of slash proc and then mounting it. Then only I'm able to see the processes within the current process namespace. But if I am actually creating if a process using dash dash mount proc option, this is done automatically. Now if I say ls slash proc, see what happens. Is it listing only the processes in the current process namespace? Yes, that is the importance of dash dash mount dash proc. Okay, so you got a clear understanding about mount proc. If you don't understand, I will again suggest you to watch this video again. Okay, now I'll tell about an important thing right now. What I want is, uh, I'll exit first. Here also I'll exit. I have two terminals, right? Now I want to launch a process in a separate process PID namespace and mount namespace. Two processes I want to launch. Sudo unshare -f pm dash dash mount dash proc, and I am launching a process bash. In another terminal again sudo unshare dash fpm dash dash mount dash proc again bash. So I am launching process 1 and process 2 in two terminals. In these two terminals, two processes which are started will be having their own process namespace, mount namespace. Now, if I do an ls slash, oh, I'm seeing lot of folders, right? Now, actually, this is like a container. This process, I can say that it is running in its own isolated file system, isolated proc file system, sorry, isolated process ID and mount namespace, right? So what I want is, I don't want this process, bash process, to see all the files on my machine. Even in here also, if I use slash, it can see all the folders. Now, I want for this uh, process in the left side, I want folder A to be the root folder. It should not see anything outside of folder A. So let us see, I'll cd into A, ls slash, still it is saying, right? Here also I'll cd into B, ls slash, here also I'm saying. I want to restrict that this process should not see anything outside of directory A. Directory A should become the root directory of this process. Yes, it is possible. So what I can do is, I will create a folder mkdir, anything like old underscore root I'll create. I'll tell you the importance of it. Ls. Here also mkdir old underscore root ls. Okay, fine. Now, to make the current directory as a root directory, there is a command called as pivot underscore root. Sudo pivot underscore root. I want the current folder to be the root folder dot, and I want a backup of the current folder in old underscore root. Oh, sorry. What is it saying? Fail to change the root from dot. Device or resource is busy. Resist ls. Fine. I'm in the directory A. Other processes are not. Nothing is there inside A. Um, Sudo uh, ls-al. Okay. Sudo pivot underscore root. Current folder I want and old underscore root. Again, it is saying old underscore root. Fail to change the root directory. It is busy. It is saying. Okay. Hey, we are getting this error because of one reason. Whenever we are using pivot root, I'm trying to make the current directory as my root directory, right? So I forgot one small step. The current directory should be a bind mount. We should have made it as a bind mount. So what I will do is I'll go back. I will do sudo mount dash dash bind slash a, the current directory, a directory onto itself. So then it will become a bind mount. So before doing this, suppose if I say df slash dash a, you can see slash a is not a mount point. So whenever you are making a directory as a pivot root, it should be a mount point. So that is one thing. So what I'll do now, sudo mount dash dash bind a onto a. Okay. So now if I say df dash a, this current directory a is a mount point. Then I will cd to a, and I want to make pivot underscore sudo, first of all. Sudo pivot underscore root current directory. I want to make it as a root, and old underscore root. This should be the folder in which it should take a backup. Okay. So I have done it. Now, the current process cannot see anything outside of slash a. Suppose if I try to execute a command, I went out, and if I try to execute ls command not found, because under slash a, is there executable ls? No, right? It is not able to see actually, right? So, ls slash ls command not found. Normally, whenever we make a folder as a root, we need to make sure that in the root directory there are some basic kernel utilities like ls, mkdir, all the basic things, whatever you want. So basically, if you want some core kernel related files, there is a file system called as Alpine file system. I'll Google Alpine file system. Okay. Here, if I go to alpinelinux.org, from here I can actually download the minimal root file system. This is the one under x86. I'll copy this path. Now I'll go back. Anyways, I will exit out of this process right now. ls. I'll go inside a ls. I want to actually download that Alpine file system. Yeah, wget. Let me download it. Yep, ls tar hyphen xvf. I'll extract it. Yes. Now you can see in this current folder you have slash bin. Now if I execute slash bin slash ls, will it give me, sorry, slash bin slash ls? Is it giving me the listing? Yes. So these folders contain the minimal file system required. Now what I will do is, current directory A is having the folders which contain the minimal root file system. Now again, what I'll do is, I'll come back. I'll use unshare again command. Unshare to create a separate file and namespace, sorry, process namespace, and dash dash mount proc will actually create a mount namespace as well. Then ls, I'll go into directory A, ls, ls old underscore root. Is there anything under old root? Nothing. Now I want to make this current directory as a root directory. So what I can do, let me first of all see df-a. Is there a mount point A current directory? No. So whenever you want to make a current directory as pivot root, the current directory should be a mount point. So what I can do is sudo, I'll go back first of all, sudo mount dash dash bind a on a. Now if you see df dash a, you will see that slash a is a mount point. Then I can make a directory as a root. So now I'll say sudo pivot underscore root dot current folder has to be the root, and old root should contain the backup. Yes. Now if I do ls, yes, I'm getting all these folders, right? Now I'll try to go to outside of a. Now if I try to ls slash, see, slash means right now the current folder only. So it's not actually seeing the slash about. On the other terminal, let me clear this. And if I say slash ls slash, these are all the folders. But the current folder A is a root directory. So normally in containers, what we do is we use something called as Alpine, which contains the kernel base kernel files, the kernel file system, minimal root file system, or whatever files, and then I'll make the current directory. So now this container cannot see anything above slash a. So I can say that this container has got its own file system, which is not visible to other containers. So like that, by using mount namespaces, what we can do is, see, this is the actual machine and it has operating system. What I can do, slash var slash lib slash my containers. I can, let's say I'll create this. Now, whenever we use unshare command and create pid namespace, mount namespace, we can create multiple processes in their own pid namespace, mount namespace, and we can run applications inside them. Now, for I can say this is a container, right? Because whatever we are running inside it is isolated. So for this container, I can say slash 1234, for example, is the pivot root. So this process which is running within the container cannot see anything outside of 1234. Again, for this container, maybe again slash var slash lib slash my containers, whatever is a folder name, slash 5678, whatever. This folder can be made as a root. So the process running here inside this particular container cannot see anything outside of it. So every process will feel that it has its own file system. So that is advantage of mount namespaces. Okay. So that's all. I will see you in the next lecture.